In this video, we are going to continue building our ramp to jump off into Link, and we're going to talk about anonymous types, which was added as well in C# 3.0. Anonymous types are on-the-fly classes, unnamed classes. And the key to this is that the compiler infers or figures out what the type definition looks like based on the object initializer. Hold on a second. Before I move on, let's really digest what this means. What we're talking about here is a class that you define in as little as one line of code. You create an instance of that class in the same line of code, and you initialize some values in that same line of code. All one line of code. That's pretty wild, isn't it? Sounds crazy, right? Well, one line of code to do all three things at once. Well, there are some caveats and there's some exceptions to that, but that's it in a nutshell. So you might wonder, why in the world would you need such a crazy thing like anonymous types? But they're actually used extensively when working with Link, and so we want to get our heads around them before we start looking at some real Link examples. Alright, so if you take a look, I've got a project here called anonymous types already set up. Now, from the first video of the day, you'll notice that we had, I pulled all that code over to create an order definition, an order item, and an address. I'm not sure that we're going to use all of this, but I copied it nonetheless. So if you take a look at this first example here in our static void main, we create a new instance of order, and then we use our initializers to create a new instance and pass in all the, or several of the default values here, like order ID, order amount, order date, and so on. So, here all we're doing is like we did in the previous example, we're just going to get the type and print it to screen. So let's run the application. Well, it would help if I did something like that. This. Now let's run the application. Alright, so the data type for order 1 is anonymous types.order. That's just what I named the project. That's probably poor naming on my part, right? It gives you the project name dot the data type, which is order, because it's an instance of the order class. Okay, that's pretty obvious. Well, let's take a look at another example. Alright, in this particular example, I'm using the var keyword. Let's start over. Alright, so in this particular example, I'm using the var keyword. And, I think that C# will have no problem figuring out that it too is of type order. Alright, so that's all pretty easy stuff. Let's move on. But you want to see something really crazy? Check this one out. Look at this. Var order 3 equals new what? There's no order there like we see in the previous ones. Just new. New, and give it these properties and these values. And now let's see what type that brings back. Let's run the application. And whoa! We get some really crazy value here. Alright? This created an anonymous type, a type automatically generated by what the compiler was able to infer about this class's structure, and it gave it this name. This name is no problem for a computer to figure out. For us, it doesn't look very readable. All right. So let's do this. Let's have some fun about it. Let's fun with it. Let's see if we can do something like this. All right. Var order 4 equals new. So it's almost identical. I have some different values in here, but the properties for our new anonymous type are in the same place, and we've defined everything. Let's see if those two use the same type, and they do. Look at this. Look at the last two, order 3 and order 4. If you compare the two, they have the exact same definition for the anonymous type, so it's reusing that type. Alright, well, let's get a little creative here. Let's copy in another example and point out the difference. Alright, so here this looks the same. Wait until we get to a new property that we're setting to the value of ABC. What happens now? Let's run the application. In this third case, see, in order 3 and order 4, they're both using anonymous type O prime 2, I guess. Here, we're using an anonymous type of 1 prime 3. Huh. So it created a new type. And notice that it becomes obvious now that it's defining not only the type class name, but also the parameters that go within it through, again, local type inference. Interesting. Okay, let's move on. What if we do this? All right, so this order number 6, it looks identical to orders 3 and 4, but I did something different. I changed the order of the order ID and the order amount. I switched them around so that order ID is defined second and order amount is defined first, unlike the two previous orders that we've instantiated. Let's run the application and see what happens. All right, so we're interested in order number 6. Oh, it created a new anonymous type for that. It did not recognize these as being essentially the same type. Okay. All right, let's do one more thing here. All right, in this case, we recreate orders 3 or 4, but we change the name of the property. So here we have order amount as the property name, but we keep the same data type here, where we call it here my order amount, but it's still of type decimal. Let's see what happens this time. Oh, it creates yet a 4th anonymous type. All right, so why is all of this important to our link story that we're telling? Well, anonymous types will be used all over the place whenever you need to shape the data that's returned from a link query. All right, so let's do this. Let me comment out just all this stuff here. All of it. All right, let's move on down here. All right, so you can see first of all that I am using a method called setup orders, and I've already had that setup orders method added. And all I'm doing here is just creating a bunch of orders. You know, I'm not even being very creative about it. Just kind of pushed it through, created a bunch of orders, and added them to a list of type order. And I'm returning that. So we have some data to work with. That's all we're doing there. I'm going to go ahead and shut that back up. So we should have a list of orders that we can play with. Now what we want to do is select, or from O in order list, select new, and then I use an open bracket and a close bracket to do what's called projection, and that means I'm going to create a new anonymous type that has these properties that I'm creating from scratch. They've not been defined anywhere in the code of an order item, and so on. And notice what I'm doing here. Order ID is pretty easy. I'm just pulling over the order ID from essentially the order. But the items to ship, here I'm grabbing a sum of all the order items quantities together. So whatever the quantity value is for order items, sum all those up and stick that value in items to ship. And then we're just pulling over the order date. Let's take a quick look at this setup orders and see what we might expect to see here. All right, so here is order item, or order 1, and then here's a number of order items. And notice that I'm adding those order items to order 1. This first order has one order item that has a quantity of 2 and another order item that has a quantity of 3. So we would expect when all that gets rolled up and projected into items to ship, that would be the value 5. But also notice I'm defining an anonymous type. This type is nowhere to be found except in how I am on the fly projecting a new data type. Then what I want to do is display what type this actually is. What are we getting back here? And then finally, we're going to start rolling through. And again, here we're using var. Who knows what data type this is? So whatever this is, this right here, this new, well, give me that. And let's loop through them all and let's start printing them out the screen. Right? So let's run the application and see what happens. Hopefully it won't die. Whoa. Stinky. Here, hold on. Let me fix a few things. Alright, so to fix the problem, I just added this line of code that basically, in the constructor, will create a new list of order items. We never newed it up, so it's fine now. Let's go ahead and run the application again. Okay, so here's the interesting part. The data type for my orders is system.link.enumerable, where select list iterator, and then the anonymous type. But the second part's a little bit more interesting. Notice the projection. Order ID, and then the items to ship. So that's what the notion of projecting actually means. It is shaping or crafting the data, the output of a query, to represent the data that you actually want. So it's doing a lot of the heavy lifting here. We didn't have to do iterators through or anything like that. We were just able to use a really simple, compact link statement using this sum method, which we'll talk about later, using this lambda expression, which we'll talk about later, to create a new type. And then use that type, loop through the collection of those new types, and print them out to screen. All right, so this is fascinating, right? It's very powerful stuff. We were able to accomplish a lot in just a couple of lines of code. Imagine if you were to, and you know what, this might even be a great exercise. Recreate that example using just the code before you've learned about vars and before you learned about anonymous types. Tell me how much code it would take to do that. Lines and lines of code to accomplish the same thing that I was able to do here in just a couple of lines of code. It's amazing. Okay, but again, this is a building block, a feature of Link that we're going to harness and wrap our heads around and use in our applications because it is so powerful. Okay, so in the next video, we're going to talk about the sum method. Well, maybe not sum particularly, but what is it? It's an extension method, and we'll talk about those in the next video. See you then. Thank you.